So now, if you remember from our previous sessions, right, we had a discussion about uh, how exactly we can ELF internals, how does it look like? Okay, and we also looked at other aspects also, yeah. So in that process, I had one small example to showcase. Let us have a look at that example and then we will continue with the other thing actually, okay. So normally, right, if you take any of the C program, right, rather than generic C program, the C program what we write in GCC, right, it has certain sections, okay. For example, if you look at your GCC sections, right, you'll find two sections called constructor and destructor, okay. So means you can whatever normally, right, whenever you define any of the classes, okay, so and if you define the class as static, right, the function which has to be called on the startup of the because whenever you define any function as static, right, basically the constructor has to be called on the startup of the program itself, okay. So at that time, so all those particular function which need to be called at the startup of the program, right, will end up in a constructor. And similarly, whenever it has to be cleanup has to be called when the program is about to close, right, it will come up in the destructor, okay. So now in this example, we will just have a look and see what exactly we need to define as a constructor and the destructor. Okay. So now if you look at this example, right, I've defined some attribute called sections and where I can define my own section. Okay. So in this case, I'm defining a function pointer and that function pointer and is telling that it is part of the constructor or the destructor. That is what I am doing. And one of the function what I defined, right? I'm assigning it to this specific section called constructor, and the same function I am putting into the section called destructor. If you can check out here. Okay, so this is one thing, and you can also specify the priority for that particular thing, constructor or destructor, right? You can also specify the priorities while telling what should be the constructor and destructor. So if you look at this example, right, I've defined a specific function and you can also, there are two ways of doing it. One way is you can define a section and you can tell this is a constructor or destructor and you can define them. Okay, as you can see in this example. In the other example, you can tell them that while defining a function, you can tell them this is the constructor. Means it has to be called on the startup of the program, something like that. You can define it and you can give a priority telling that what should come first. Okay, in this case, I've given a priority of 101 to this and 102 to this. Okay, so like this, you can also specify the priority and the order of function, which function has to be called first. Okay, like that also you can define it. And these are more internal to the your GCC implementation itself. Okay, so you can specify the attribute and you can tell what function has to be called first. So basically in the C program also, you will be able to define the constructor and the destructor. That is something what I want to specify in this specific example. So now if you look at this example, right, in the main function, I'm not called anything. So if you look at in my main function, I've called only the, I'm printing some function telling that this is the main body of the program. Okay. So, but rest of the function, for example, this is defined as a constructor, as you can check out here. And then I've defined one more function called ELF init. Okay. So, and in this ELF init, I'm telling that this belongs to a new section called init. If you remember, there is one section called init, and init is something that will be called first. Okay. So I'm defined this function, I've defined a new section called init, and I'm telling that this part of the code belongs to init section. That is what I have told here, and I'm telling that it has to call ELF init. Okay, so I've defined it and I specified this function to be part of a dot init. That is something that has happened, and I've defined everything, and then I've set up everything in this case. Okay, so let me compile this program and let us see what really happens when we try it out. Okay, just give me a second. I'll open a terminal here. Okay, so if you take this, so compiled it. Now, if you see here. So let me open the program and we will have a look what in which order it is called and why did it call in that particular order. Okay. So if you see here, there is something called init some function basically. If you see here, it is telling that init some function. And if I look at it, where did it come from? This one. Okay. And this is the function what I have defined telling that I'm told as init some function. So if you look at this function, so if you look at it, So init some function is the first function to be called from this ELF init. Okay. So and if you look at here, this ELF init, I've told that it should be part of a dot init. Now, if you look at this flow, the first function to be called is your ELF init. That is something what you can see here. Okay. So the ELF init, the ELF init is called first. So that is the reason this init function got called first, as you can see here. Then after that, the next function got called. Okay, so which clearly indicates that init as the highest priority, and this will be the first section to be called. And if you see here, this I have not called anywhere in my main program. So my question is, how did it get triggered? If you look at it, the main reason is GCC first starts the program which which executes the code which is part of the init section, and that is what you can see in this particular program. And if you see here, that particular program, whatever we defined as a part of a init, right, got executed, as you can check out here. Okay. And then, so it got executed. And then after that, if you look at here, a constructor one and constructor two got called. And if you look at it, what it is, the second thing what gets called is your constructor one and constructor two, whatever I defined. And if you see here, I'd assigned a priority telling that this should have a highest priority and this should have a lowest priority. And that is the reason this got called first and this got called next, which is part of this attribute called constructor. Then after that, one more section which I defined as told that this is also part of the constructor got triggered next. And if you see here, this got called, the same function got called twice because I've defined it twice here, if you look at here. And then after that, my main program gets executed. So only executing after init and the constructor sections, my program gets executed next. That is what you can see here. Now, my main function exits by return of 0. But it doesn't go out just like that, if you look at here. The next function that will be called is my destructor. And if you see here, I define a destructor of type test that gets called first. And then after that, the priority tells, if you look at the priority, doesn't mean that which destructor gets called first. This priority tells that in which order it has to be called first. And if you look at here, I've given the priority of 101, so this will be called last. So that is the reason this is called last and this is called before that, and after that the test got executed. If you see here, the main thing what I wanted to mention here is you can assign all the priority whatever you want, but 0 to 100 are normally reserved and you're not supposed to use them. But if you want, you can use them also, but it's all normally reserved. So you should use priority which is greater than 100. So that is the reason I've used the priority of 101 and 102 in this specific case. So the main thing what I want to stress here is that before my main function, my init section gets triggered first and my constructor section gets triggered next. Then my main body gets executed. Then after that, the destructor gets called one after the other. Okay, just similar to your C++ program, right? Similar kind of behavior you can see in this specific example also, as you can see here. Okay, so you can check it out. I can define any number of constructor. That specific thing gets called first. For example, where it is useful, for example, let us assume that you're defining a kind of a library, and then on the load of the library, you want to do some setup. At that particular time also, you can trigger some kind of a constructor or init section, whatever you want, you can define it. Normally, people prefer to do constructor because it'll be called on the startup of the load of that library, and it'll be called on the unload of that library. That is also possible. Okay. Or else you can also define an init section and a finite section, which will be called once on the program start and once on the program exit. That is something what you'll be able to do. So you can define any of the things if you want to do some setup before the program starts and some cleanup when the program is about to exit. Okay. So this is something which you will be able to do, which is normally not part of the standard C program, but which is tightly coupled to your GCC itself. You can do it, and that not that just that alone, you can also specify the priorities also. As I mentioned in this program, you can define what should come first. For example, let us assume you want to do some setup, and then after that, you want to do next setup after that, and after that, you have to do some next step after that. Okay, so if you have some specific sequence of order to be followed, then this priority will assist you to do that particular action at a great ease. Okay, so this is something which I wanted to stress in this specific case. Okay, so why I'm talking about this is because if you look at the whenever we looked at the ELF internals, right, we looked at this specific section also. I just wanted to stress what is the importance of this and how does it play a role in this specific scenario. Okay.